Hello everyone, this is the second part of chapter 10 video about classes. We are introducing classes, and in the end of the first part I talked about the shortcomings of the class that I introduced earlier. Um, Now let us quickly go back to that example and modify it a little bit. First of all, to hide the attributes, which again is really good because you don't want, say, somebody who is using this class to enter a number for a name or name for a number for an attribute that should be a number. So you are hiding the attribute in this way. And also I have a get name and I don't have a set name. Maybe I should have a set name to change for completeness, because this is the regular pop that classes are supposed to have. Def set name self new name. And of course, what I'm going to do there is just reset the name to new name. So double underscore self.double underscore name is the attribute. It is the hidden attribute that we're working with, and we want to replace it with new name. All right, so now we have getter and setter for the attribute name, and it is questionable really in this problem whether I want to have a setter. From the point of view of the class insect, it's not gonna become a spider from a housefly. It's not going to transform randomly. But I have done the trivial and necessary part of the class. That is init. Double underscore means private or hidden attribute and or method, and double underscore on both sides, that is standard. This is a standard method. So init is a standard method that every class is supposed to have, and using that, this class, you can define your attributes, and this is how you define your class. Okay. So I have made a provision for a public method catch. The insect will catch another insect. And so far, it's nothing, just pass to not have any error message when I run this. And I created 3 instances. So insect, housefly, another housefly, and spider. So those are the names of the variables, and fly1 is storing an object, insect, housefly. Fly2 is storing a different object, which has the same attribute. They are not the same. And finally, spider1 is yet another object. So first of all, let's test that this works. And it ran, nothing happened, because besides just creating objects, and once again, instance is the same as object, I have done nothing with them. So just for an example, sorry, I'm going to do fly1 dot get name, and it refers to a housefly. So it's not good to print like this in a program. It only works when you have just one thing to print. If you actually have printing statements in program, you have to kind of get parentheses around it and write the print. Okay, but for the testing, debugging, and this kind of rudimentary showing things, it's good enough. All right, so how do I want my catch to work? For example, I want to call spider1 dot catch, and in parentheses I will have fly1. So this is how I'm going to call it. Spider1 dot catch, that means spider1 will catch fly1. And what I want to see is like a printing statement, spider caught a fly, or caught a fly. And we are taking, notice here, we're taking another object, other insect object, as a argument, and we are returning the value based on that, based on catch with an argument. A very similar thing you will need to do for your weekly homework. And yes, feel free to ask me questions if it's not clear, send me code. Please don't copy paste the code from online. Okay, so how are we going to make it work? So the idea is the following. If my insect is fly and it catches another fly, we will just print that they are playing. If my insect is spider and it catches another, it catches a fly, then we will print caught a fly and ate it, something like that. So that is the plan. And how am I going to do this is I'm going to have an if statement. If other insect object dot get name equals to housefly, and self name, self double underscore name, sorry, I need a double equality there to check. Self name equal to spider, then all I do is a printing statement yeah, just spider caught a fly. So what happened over here? If object get name dot get name, we are working with some other insect object, and we have to use get name because the name for this object is not public. It is a hidden attribute. So that's why we do get name. But when we work with the current object, with our object, we can do just double underscore name equals spider. Okay, so in this particular case, spider1 dot catch fly1, this means that spider1 is our self. So self dot underscore double underscore name is spider. That we can call it like this because we are inside spider object, spider1 object, and fly1 is my other insect object, so we have to call get name. All right. And another case that we want to cover, let me just copy paste and modify. Our object is housefly and the other object is also housefly, and the statement will be two flies are playing with each other. So nothing terrible is happening to them. Okay, so let's see if it works. I think this example is rather similar to what I would expect from you in your homework about the farmer. All right, let's see. Spider caught a fly. That is one example, and there was only one printing statement to be made here, and we can ask or try to do more, like fly1 dot fly2, sorry, dot catch fly2. Let's see if that works. So the fly1 really was not deleted because it was killed. Okay, so this is a very, very basic class, and I should slightly enhance it by introducing another standard method that will be useful to us in many occasions. That is a string method. String method, double underscore string double underscore, and as I was telling you later, that means it's a standard method. What's going on here is you are telling what to do when you print. For example, I want to print fly1. Actually, I can just do it before and after. So far, this string method was not created. Print fly1. So this is an insect object, and this is actually the address in the memory where it's stored. So not very terribly informative. That is some information that can be useful, but we would like to actually control what is being printed when we call print on an object. So we will return whatever string we want. This is Vlad's insect object. Escape character over there. And plus, well, maybe object and name is self dot double underscore name. So this will create a string. This will create a string. Plus means concatenation in terms of strings. Both of my ingredients are strings, and I will print what this fly object is, and you can see that you can create any printing statement explaining what the class is, what the attributes are, and it should work with for any instance of your class. Oops, we're having a trouble with indentation apparently. Let's rerun it. All right, very well. So this is Vlad's insect object. Name housefly. Well, that is all for this modified example. Compared to the previous version, we hid the attribute that we have, and also we created a method to catch another insect. And we could develop it in some way, but that's good enough for the first example. Let us finish quickly the theory, and I will use this opportunity to actually run through, do a quick run through what we have covered so far. So this is a great slide, what the objects are. You are creating a class, and from this class you are creating a specific object. Now, specific object is what you will be using in your programs. For example, your object can be in-game bot character. So object will have data attributes, just data, and also methods. And in a better picture, so methods are changing the data attributes. They're also in charge of interacting with the outside world, with the outside program. So some of these methods like getName or setName, setters and getters, are in charge of returning those attributes as needed. And that is again very important because you want your object to get only correct attributes, and your method, for example, can check what data type or if the data is making sense, like do the input validation at the moment when the object is created or when attribute is being updated. Okay. We want to hide data, as I was saying, and we want our object to be reusable. So same 3D image object can be used for architecture and for game programming. That would be an example that the book is making. And finally, one more very useful example or mindset. Blueprint is our class. Class does create provisions for specific parameters of the house, in this case, of this blueprint, and how this house will be built, what it will contain on some level. However, each house can and should be rather different. If your class is well written, there is diversity of objects that can be created from it. And we're not going to do that completely. We're not going to come even close to a full understanding of what classes are. That is a year in or two in the future of your programming career. And there are BIPSI classes, follow-up classes, where you will work a lot with objects. So do pay attention, but don't expect to learn everything from these videos. This is just an intro. So it's a blueprint that from which we are building houses, and the blueprint does not know about how many people live in the house, what's the color of the house. It can have provision for having a color for the house or for having number of people living there, not a fixed number, hopefully. And it can have blueprint should allow to put furniture inside the house. So blueprint is responsible for a lot of things, starting from utilities, but it does not completely determine the house. It just allows for enough attributes to be specified at the moment when you create an object from this from this class. All right, and we have talked about class definition. So class is the keyword, class name is capitalized, and self parameter will refer to the corresponding instance of the class that is being created. So self, if I created fly1, then self is corresponding to this fly1 object. We have talked about the init method. This is the method in charge of creating the class and initializing the class, and also creating the data attributes. So if you want your data attributes, you to supply data attributes at the moment when object is created from this class, you have to specify them here and inside the init function, as we were doing. I will shortly play with the coin class and create coin objects, and let me mention a little bit about the string method. I don't think I did anything with it. So double underscore on each side means it's a standard private method that is the method in charge of inner workings of the class, and this method is called when you print the object. And you can completely specify what kind of information is printed about your object. So there are class attributes and instance attributes. When you are creating a specific object and give it, for example, specific name, this is an instance attribute, as opposite to class attribute, which is just a abstract variable. All right, so we will work with this. We will create a coin class shortly. And yes, going back to getters and setters. So just for you to be aware of this terminology, because you will need it for the quiz. Sorry. Getter is the accessor method, so it accesses an attribute. And setter is a mutator method, which is setting a new value to the attribute. And in general, in serious big classes, the getter will, well, probably just return the name, or maybe it will format it in a nicer way. And it could do something extra. But setter, when you set a new name, set a new value to your attribute, you actually have a little bit of a work here to do in terms of validating the input. So a programmer will be using this class, and you need to make sure that the input is not too wild and that will not crash some other private method that is using the name attribute. For example,